that we can find where the module crashed and things like that. Maybe a future video on using the debugger. As you can see, the text is now being printed onto the screen, and I am blind, so it's kind of hard for me to see the green or yellow, the color on the screen. But in order to change the color, we can call the function set text color. RGB is a macro, and these are the RGB values, red, green, and blue values. Okay. And there we go. Text is being printed here. I think 100 lines may be a bit too much. Let's reduce it down to 50. Okay. Good enough, I suppose. Okay. So let's try it one more time to make sure that it's working. I'm going to put this here. Okay. Accelerating time. Four, three, two, one, and boom, all the vessels were destroyed. Okay. The second part of this video will be to actually create an MFD that will allow you to create the shuttle PBs so that you can use them as a bomb or something or whatever. I just think that it'll be a good practice. So to cap what we did, we added two functions here, callback pre-step and callback draw HUD. Callback step is called by our orbiter every single time step, and callback draw HUD is called whenever the HUD is read. Here we draw our text, some information. A lot of times people just draw information on the bottom left hand corner as a debug string, and debug strings are only meant to be used in debugging. Actually, let's see. OP debug string. See, this function should only be used for debugging purposes. Do not use it in published modules. Okay, and inside pre-step we check when the creation time plus the explosion time, which is 200 seconds, is greater than the sim time. When it is, we iterate through every single vessel. Each vessel has an index number of 0 to the number of vessels minus 1. It can have an index number anywhere. Any vessel inside the simulation will have an index number from 0 to the number of vessels minus 1. So all we're doing is we can get the handle, the object handle of the vessel, by giving it an index number. So we iterate through every single vessel and get its global position. We have the global position of this vessel, the bomb. Compare the distance. If the distance is less than the damage radius, we delete that vessel, and then finally we delete ourselves. So this is pretty straightforward. This function callback set class caps. Here we initialize the vessel's basic parameters such as its size, its empty mass, and things like that, and create any particle streams and all that stuff. Give the touchdown points and the docking parameters. Set the lift coefficient function, and add the mesh with the add mesh call. These two functions are very important This one basically orbiter calls this whenever you create an instance of shuttle PB, and this one orbiter calls when you delete the shuttle PB. Okay, so one last time compile. Okay, now we're going to create the MFD. So I use the custom MFD as a template, and we'll call it bomb MFD. Delete this file. Bomb. Uh-oh. Okay, we open the project, convert it, go to the properties, debugging, command should be set to orbiter, and working directory. This is very important, otherwise you'll see no scenarios. Working directory should be set to orbiter's root directory. Again, in debugging it should be multi-threaded debug. And this one has to be inside the plugin directory. Oh yeah. Update the references. Add existing items. Alright. Here we're going to delete the comments. You don't need that. Update this to bomb MFD. Deleting all the stuff that we don't need. This should be set to bomb MFD. This is a key that'll bring it up after you press Alt F1, or is it Shift F1? I'm not sure. Okay. This is the constructor. We don't want a graph MFD, we just want the MFD. You can derive your MFD classes. You can either have a graph MFD or just a simple MFD. We're not going to create any graphs, so we just want a simple MFD. We're gonna want to come here later.